Assalamu alaikum, brothers and sisters. Welcome to the journey of Quest, where we quench your thirst of knowledge. Today we will explore the fascinating field of remote sensing for glacier study, the tools and techniques used, and how the integration of artificial intelligence, or AI, is revolutionizing our ability to generate valuable information from glacier research. Glaciers are critical components of the Earth's cryosphere, and understanding their dynamics is essential for climate change studies, water resource management, and disaster mitigation. Glaciers are sensitive indicators of climate change. They store about 69% of the world's fresh water and play a vital role in regulating global sea levels. However, due to global warming, glaciers are retreating at an alarming rate. Studying glaciers helps us monitor climate change impacts, predict sea level rise, assess water availability for downstream communities, and understand glacial hazards like avalanches and glacial lake outburst floods, or GLOFs. Remote sensing is the science of acquiring information about an object or phenomenon without physical contact. It has become indispensable for glacier studies due to its ability to provide large-scale coverage, as satellites can monitor remote and inaccessible regions, temporal resolution with frequent observations over time, and multispectral data, offering information across visible, infrared, and microwave spectra. Let's discuss the key tools and techniques used in glacier monitoring. Optical sensors like Landsat, Sentinel-2 and MODIS provide high-resolution images for mapping glacier extent, snow cover and surface features. Thermal sensors are used to study surface temperature variations, which are critical for understanding melting patterns. Synthetic aperture radar, or SR, utilizes sensors like Sentinel-1 and ALOS-PALSA, which have the unique ability to penetrate clouds and operate in all weather conditions. This makes them incredibly useful for monitoring glacier velocity and ice thickness. On the other hand, altimetry involves satellites such as ICESat-2, which measure changes in glacier elevation. This data is crucial for understanding the mass balance of glaciers. LiDAR, which stands for light detection and ranging, is another powerful tool. Airborne LiDAR systems provide high-resolution topographic data, enabling precise mapping of glacier surfaces and volume changes. Unmanned aerial vehicles, or UAVs, commonly known as drones, are increasingly employed for high-resolution localized glacier monitoring. These UAVs are particularly useful in hazardous or hard-to-reach areas, offering a safer and more efficient method of data collection. Despite all these advancements, glacier monitoring still faces several challenges. Cloud cover, for instance, limits the effectiveness of optical sensors. Complex terrain, including steep slopes and crevasses, makes data collection difficult. Additionally, remote sensing generates massive datasets which require efficient processing and analysis. This is where artificial intelligence comes into play. AI, particularly machine learning and deep learning, is transforming how we analyze remote sensing data for glacier studies. Here's how. Automated glacier mapping AI algorithms can automatically classify glacier boundaries, snow cover, and debris using satellite imagery. For example, convolutional neural networks are highly effective in image segmentation tasks. Glacier velocity estimation AI models can analyze time series SR data to estimate glacier flow velocities with high accuracy. Mass balance estimation. Machine learning algorithms can integrate multi-source data like satellite imagery and climate models to predict glacier mass balance and melting trends. Hazard prediction AI can analyze patterns in glacier behavior to predict hazards like glacier lake outburst floods or ice avalanches, enabling early warning systems. Data fusion and integration AI techniques can combine data from multiple sensors like optical, radar, and LiDAR to create comprehensive models of glacier dynamics. Let's look at some real-world applications. Himalayan glaciers' AI models have been used to monitor glacier retreat and predict water availability for millions of people downstream. Greenland ice sheet. Deep learning algorithms have improved the accuracy of ice sheet thickness measurements using satellite data. Alpine glaciers. UAVs equipped with AI-powered image analysis tools are being used to map glacier surfaces and monitor crevasses. The future of glacier studies lies in the integration of advanced remote sensing technologies and AI-driven analytics. Some emerging trends include high-resolution satellite constellations, providing more frequent and detailed observations. Quantum computing, enhancing the processing power for large datasets. Explainable AI or XAI, making AI models more transparent and interpretable for scientific research. Citizen science, engaging the public in glacier monitoring through AI-powered apps and platforms. In summary, remote sensing combined with AI is revolutionizing glacier studies. These technologies enable us to monitor glaciers with unprecedented accuracy, predict future changes, and mitigate risks associated with glacial hazards. As we continue to face the challenges of climate change, the integration of these tools will be critical for sustainable management of our planet's cryosphere. In this chapter, we will delve deeper into advanced remote sensing techniques such as hyperspectral imaging and thermal infrared sensing. These techniques provide more detailed information about glacier properties and dynamics, allowing for more accurate monitoring and analysis. Hyperspectral imaging captures data across multiple wavelengths of light, enabling scientists to detect subtle variations in glacier composition and conditions. This method is particularly effective in identifying different types of ice, snow, and debris, which can be crucial for understanding glacier health and changes over time. Thermal infrared sensing, on the other hand, measures the heat emitted by the glacier surface. This technique is invaluable for monitoring surface temperatures, identifying meltwater channels, and assessing the energy balance of glaciers. By using thermal infrared data, researchers can gain insights into the melting processes and potential areas of structural weakness within the glacier. Together, these advanced remote sensing techniques enhance our ability to study glaciers in greater detail and improve our predictive models. As technology continues to advance, we can expect even more innovative methods to emerge, furthering our understanding of these vital components of the Earth's cryosphere. Stay tuned for more fascinating insights into the world of glacier studies and the cutting-edge technologies that make it possible. In this chapter, we explore how artificial intelligence is revolutionizing climate change studies, particularly in understanding the impacts on glaciers. AI models and algorithms are now pivotal in predicting glacier melting rates and their contributions to sea level rise. By leveraging massive datasets from remote sensing technologies, AI can identify patterns and trends that were previously undetectable. For instance, machine learning algorithms analyze satellite imagery and other remote sensing data to predict how glaciers will respond to varying climatic conditions. These predictions are crucial for policymakers and scientists as they work to mitigate the impacts of global warming. Moreover, AI helps in creating more accurate models of glacier dynamics, incorporating factors like temperature fluctuations, precipitation patterns, and even human activities. These models enable us to forecast future scenarios with greater precision, providing valuable insights for both short-term responses and long-term strategies. The integration of AI in climate change studies is not just a technological advancement, it's a critical tool in our fight against global warming. By understanding the intricate details of glacier behavior, we can better prepare for the challenges ahead, safeguarding our environment for future generations. Stay tuned as we continue to explore the fascinating intersection of technology and environmental science. As we look towards the future, emerging technologies hold the promise to revolutionize glacier studies even further. Quantum computing, with its unparalleled processing power, has the potential to solve complex climate models that are currently beyond our reach. These computers can process vast amounts of data at unprecedented speeds, allowing scientists to simulate glacier dynamics with remarkable accuracy. Advanced robotics, particularly autonomous underwater and aerial drones, are opening new frontiers in glacier exploration. These robots can reach previously inaccessible areas, providing detailed measurements and real-time data that enhance our understanding of glacial environments. Next-generation satellites equipped with cutting-edge sensors and improved resolution will offer even more precise data on glacier movements and changes. These satellites will enable continuous monitoring, providing invaluable insights into how glaciers evolve over time. Together, these future technologies will not only advance our knowledge, but also empower us to make more informed decisions in the fight against climate change. By harnessing the power of quantum computing, robotics, and next-gen satellites, we can unlock new levels of understanding and protection for our planet's glaciers. Stay tuned as we delve deeper into these groundbreaking innovations and their potential to transform glacier studies. As we venture further into the realm of glacier studies, it's clear that no single nation can tackle the enormity of this challenge alone. Global collaboration has become the cornerstone of advancing our understanding of glaciers and their pivotal role in the Earth's climate system. International initiatives such as the Global Cryosphere Watch and the World Glacier Monitoring Service bring together scientists from around the world to share data, methodologies, and insights. These partnerships enable a comprehensive and unified approach to glacier research, transcending borders and fostering a sense of global stewardship. One of the most remarkable examples of global collaboration is the International Polar Year, a large scientific program focused on the Arctic and Antarctic regions. Through this initiative, researchers from over 60 countries work together to study polar ice caps, glacial movements, and the impacts of climate change on these critical environments. Additionally, collaborative efforts like the Global Terrestrial Network for Glaciers, GTNG, provide a framework for standardized glacier monitoring. This network ensures that data collected from different regions are comparable and can be integrated into global climate models, enhancing our ability to predict future changes. These global partnerships not only accelerate scientific progress, but also promote the sharing of knowledge and resources. By working together, we can leverage the strengths of diverse research teams and technologies, leading to more robust and accurate findings. As we face the pressing challenges of climate change, international cooperation in glacier research is more crucial than ever. By uniting our efforts and pooling our expertise, we can develop innovative solutions to protect our planet's glaciers and ultimately our global climate. Join us as we explore the inspiring stories of global collaboration and the transformative impact these partnerships have on glacier research and beyond. As we conclude our journey through the intricate world of glacier studies, it's vital to recognize the role of public awareness and education in driving meaningful change. Understanding and addressing the challenges posed by climate change and glacier melt requires not only scientific expertise, but also a well-informed and engaged public. Numerous educational programs and outreach initiatives are dedicated to informing people about the importance of glaciers and the urgent need to protect them. Organizations like the National Snow and Ice Data Center and the International Glaciological Society offer resources and programs designed to educate students, teachers, and the general public on glaciology and climate science. Interactive workshops, online courses, and school programs bring the wonders of glaciers to life, making complex scientific concepts accessible and engaging. Documentaries and virtual reality experiences allow people to witness the majestic beauty of glaciers and the stark realities of their rapid decline, fostering a deeper emotional connection to these critical environments. Social media campaigns and public lectures by renowned scientists and environmentalists amplify the message, reaching a broader audience and sparking conversations about climate action. Community-based initiatives like citizen science projects empower individuals to contribute to glacier research by collecting data and monitoring local glacier conditions. By raising awareness and educating the public, we can cultivate a generation of informed citizens who are passionate about protecting our planet. These efforts inspire action at both the individual and collective levels, driving policy changes and fostering a culture of sustainability. In the face of climate change, every voice matters. By sharing knowledge and raising awareness, we can galvanize a global movement to safeguard our glaciers and ensure a sustainable future for all. Thank you for joining us on this exploration of glacier studies and their profound impact on our world. Together, we can make a difference.